Today's notes are on angles and their bisectors. We're going to begin by talking about when an angle is split into two parts, but not necessarily equal parts. So you can see the wording here talks about point D being in the interior of angle BAC. So I'm going to draw any angle and name it angle BAC. And what they're telling me is that point D sits somewhere in the interior of the angle. Notice I'm putting it off center. So in other words, when I draw in, as it says, a ray that starts at A and goes through D, it does not look like it's cutting that angle into two equal parts. What I do know, however, is that these parts, angle BAD and angle DAC, will add up to the whole entire angle. So sometimes I'll look at this as part 1 plus part 2 equals the whole entire angle. Or you could be a little more mathematical and say that the measure of angle BAD, that's the angle that is on the top, plus the measure of angle DAC, the measure on the bottom, equals the measure of the whole angle that we're calling BAC. So basically, either way you look at it, whether you call it by parts or you call it by the angle name, the same situation occurs. In the section that's here, they're telling you about how to draw a picture with the wording that talks about D being in the interior of the angle. They say that you're going to start by drawing your angle with a vertex at A, which you can see it's angle BAC. So here's our entire angle. And that point D sits somewhere in the interior. Notice that that's off center, so that when I draw that ray in, it is not creating the two parts to be equal. So when I look at question number 1, I'm drawing that same picture. D is the interior of this angle, so I'm going to draw this angle BAC. The vertex is always the middle letter, and point D sits somewhere inside this angle. I'll put it here. And I'm drawing a ray from A to D and keep on going. And what they tell me in this particular question is that angle BAD, that's this angle, is 40 degrees. And angle CAD, that's this angle, it's 25 degrees. One of the things that you'll notice is based on my placement of D, this may or may not be drawn to scale. Technically, the bottom angle looks like it should be the 40 and the top one 25 because of the size that they are, but we're not going to worry about that. If it really bothers you, feel free to redraw your picture. In this case, they are asking me for the measure of angle BAC, and angle BAC here is the whole entire angle. So the measure of angle BAC is going to be equal to the 40 degrees plus the 25 degrees, which gives me 65. When it's numbers that we're working with, it is a little bit easier. In question number 2, now that we're doing the same thing, but H is in the middle, I shouldn't say middle, in the interior of angle EFG. So angle EFG, and I'm going to put H in the interior, not in the center, though I want to make sure I make it off center. The ray from F to H is drawn, and in this case they are giving me a little bit more information where they are telling me that EFG, the whole angle, is 75, and HFG is 20. And they want to know how big the angle is from EFH, or they called it HFE. Basically, the angle we're looking for, we could put an X on if we wanted to, and say that we know that the one part called X plus the other part called 20 equals 75, and then we could do the math to find out that X is 55. Or some of you may just say, well, if the whole thing is 75 and one of the angles takes up 20 degrees, then our final answer must be 55. So it's your choice, whichever one you prefer on something like that. When we get to question number 3, in question number 3, same scenario where what we're doing is we're drawing an angle. This time the angle is called JKL. So I have JKL, and KM is drawn where M is in the interior. So I'm going to put M here and draw this, and then I've got to pay attention to what they tell me. JKM is 2x minus 3, that's this angle. MKL is x minus 1. That's this angle. And then they also tell me that angle JKL is 50. That's the whole angle. So I'm going to use that same idea that we talked about previously, that part one of the smaller angles, plus part two, the other smaller angle, has to equal the whole entire angle. So the one part is 2x minus 3, the other part x minus 1, and we know the whole angle is 50. When I do the math, I end up getting that x is 18, which is what they were asking for. Be careful because sometimes they won't be asking for you to find x. You'll actually have to substitute in to find one of the angle measures. When we flip the page over, there are a couple more questions here, but these questions are a little bit different because now what they're telling you is that you will actually have an angle bisector drawn in your picture. So if we start with this sentence right here, it says angle BAC. Let's draw angle BAC, is bisected by a ray that starts at A and passes through point D. So what that means is now point D has to be located in such a place inside the angle so that when it's drawn in, the whole big angle gets bisected into two equal parts. So those two angles should be equal to each other. I'm going to call the one angle, angle 1, and the bottom angle, angle 2. So there's a couple of things that I know. First of all, what I know if AD is truly an angle bisector is that angle 1 should turn out to be congruent to angle 2. In addition, angle 1 plus angle 2, I should probably put measures in there, equal the measure of the whole entire angle, angle BAC. So essentially this is part 1 plus part 2 equals the whole entire angle. As a side note, I also would like to point out that if you are talking about the measure of angle 1, it's basically half of whatever the whole entire angle measure is. So if I was to tell you that this whole angle is 50 and you were looking for the measure of angle 1, it would be half of 50, which would turn out to be 25. So each of these angles then would be 25. That only happens when the ray that's drawn in there is an angle bisector. So in this section here, they're telling you when you're told that the angle is bisected by AD, you want to draw your angle with your vertex at A, and point D needs to sit somewhere in the interior of the angle such that the two angles that are created are equal to each other. When we go on and look at the next question, in the next question, it is talking about us drawing our own angle. It's telling us that BAC is bisected, so this is the exact picture that we just talked about. So here's angle BAC, and it is bisected by a ray called AD. Doesn't really matter where D sits as long as it's on that ray. Angle BAD is 40, that's this angle here. And they're asking for how big the whole entire angle is. They want to know this angle. So we have to go into this and say, well, if the one part of the angle is 40 and this ray is an angle bisector, then the other part must be 40, which means then that the whole entire angle that they're looking for should turn out to be 80 degrees when I add them together. So 80 degrees is what I get for my final answer. 40 plus 40 is equal to 80. For question 5, it's the same scenario. I have an angle that's being bisected by a ray, so I'm going to draw the same picture. The name of the angle changes, but the scenario remains the same. And FH bisects the big angle. So basically this part and this part are equal to each other. When I put my information in, they're telling me here that angle EFG, that's the whole angle, is equal to 110. And it wants to know how big angle GFH is. That's this angle. Well, the measure of angle GFH because it's half of the whole entire angle, is going to be 1/2 of 110, which is going to turn out to be 55 degrees. So technically the lower of the two angles, part 2 and part 1, if they had asked that, are both going to be 55 degrees. This is particularly, though, the one that they were asking for here. And in question 6, we have the same scenario. We have an angle that's being bisected. So I'm going to draw this. Here's my angle called PQR that's being bisected by a ray that starts at Q and goes to S. PQS, this angle is x minus 8. And PQR, be very careful on that, PQR, that's this angle, is 5x minus 100. Sometimes kids will tell me that they want to set those two expressions equal to each other. Please be very, very careful not to do that, because in this situation, that would mean that you're saying that half an angle is equal to a whole angle, and you can't do that. So basically in this case, what you need to remember is if one of the two parts is x minus 8, and this is an angle bisector, then the other part must also be x minus 8. So I essentially have two angles measuring x minus 8 that has to add up to the total angle of 5x minus 100. So I get 2x minus 16 equals 5x minus 100. When I solve, I'm going to minus the 2x, and I'm going to add the 100. And I end up with 84 equals 3x. And when I divide, I end up getting 28 for my answer for x, and notice that is what they wanted me to find here. So 28 is going to be my answer for x on that one. Okay, we have one last question on the next page, and on this last question we have an angle being bisected. So here's my angle JKL that is being bisected by KM. JKM, 7x plus 14. MKL, 5x plus 40. In this case, what they gave me was 1/2 and the other half. And if this is truly an angle bisector, then I know that those two parts are equal. So my equation is going to be to set the two smaller angles equal to each other. I'm going to minus the 5x and minus the 14 to get that 2x is equal to 26, and therefore x is 13. Please be careful, because in this question, not only did they ask for x, but they also asked for the measure of angle JKL. Just as a note, that is the whole angle, which will be equal to whatever we get when we take that 13 and substitute it back in. So if I put a 13 in right here, that's 65 plus 40, which is 105. And when I take the 13 and I put it in here, 7 times 13 is 91 plus 14 is 105. So the measure of the whole entire angle, which is what they were asking for, is going to be 105 plus 105, which will be 210 degrees. So we have to add them together in order to answer their question.